Hey everyone, let's go ahead and see how you can design RAG with the Langgraph agent. In a previous couple of lessons, we have seen how you can start with the semantic search, and we had also seen that how you can implement RAG with the Langchain agents. So this was the foundational RAG kind of the lesson where we had seen mainly how you can ingest your data. So we have ingested one of the research paper on the large language model in the Chroma DB. And then in the second lesson, we had seen how you can implement full-fledged RAG with the Langchain agents. For your learning purpose, in this particular lesson, I'm going to show you how you can implement RAG with the Langgraph agent. Moreover, the final outcome will be almost same like we have seen here, only the implementation is going to be different here. So you will get also opportunity here to learn the Langgraph. Let's go ahead and get started with this. I have prepared here a presentation, but before we move ahead, let me just tell you a couple of things. First of all, the code which I'm writing here, you can get it from my GitHub repository. So you need to come here at GitHub, Lakshmi made it, Langchain V1 project. You can get the project here itself. As you see, all these three projects are uploaded here. The other thing here, I would like to tell you there, we are going to use a Langsmith to trace our LLM so that we can know that whatever intermediate steps are being taken by the agents, we can monitor all those intermediate steps using the Langsmith. Other than that, we are also going to use here Ollama for a local LLM. And if you are a beginner for the Ollama, you do not know anything about the Ollama, then you can come to my channel KGP Talkie. There in the playlist section, you will get the local LLM tutorial. There you can learn about the Ollama. And this is the research paper which we had ingested in the first lesson. That is a survey on large language model with some insights on their capabilities and the limitation. It is 174 page research paper. So this paper we had ingested, and that paper is currently here in the Chroma DB. And this we did in the first lesson. And this is the first lesson. In the first lesson, as you see here, let me just show you here, we must be having somewhere our vector DB configuration. Here it is, the PDF collection. That's the collection name. And here is the persistent directory. This directory name we have here. All right, let's come to our presentation. So this presentation is also provided with the code file. You can download it from the GitHub. So what we are going to do here, we are going to use following technology. We will be using a vector database like a Chroma DB. We will be using Ollama embedding method to embed text data into the Chroma vector DB. We will be using here a Qwen3, and we will be connecting Qwen3 with the Ollama, and we will be using here chat Ollama, that is the Langchain Ollama library. We will be also using here a retrieval tool. Basically what we will do here, we will implement our own retriever, and then we will use their tool decorator to make sure that that work as the LLM tool. And then finally, I'll show you how you can implement final graph workflow. We will be using here state graph. One more thing I would like to tell you here, that if you are super beginner to the Langgraph and Langchain and you are looking for a full-fledged Udemy course, then you can also see that course here. You come here in the README file. Thereafter, you will see Agentic RAG with the Langchain course. You can enroll in that course. There is the Master Langgraph and the Langchain with Ollama. You can enroll in that course. There is another course on the Master Langchain and the Ollama. You can enroll in that course as well. All right, let's go ahead and get started with the coding part. So first of all, what we have to do here, we have to import all the necessary library. But before that, we have to install it. So these are the library which we are going to install. Let me just close this presentation. All right, so we are going to install here pre-release version of the Langchain. At the time of recording this video, Langchain version 1 is not released as a stable version. That means it is available in a pre-release version. So you can use this particular command to install it as a pre-release version. But by the time you watch this video, you might see that stable version has been published by the Langchain. So in case of the version 1, if stable version is released, then you need to use this particular command. So I have used this particular command as of now. All right, perfect. Now let's go ahead and start importing necessary libraries. And before we import, one more thing I think I should tell you, this is the overall architecture which we are going to implement now. All right. So this is the overall architecture. Once we have imported all the necessary libraries, then I'll go and explain all these architectures to you, that how it is going to work. All right. So first of all, what I do here, I import necessary library. So what are the necessary library we are going to import? We are going to import literal, base model, field. All these we need to do for the type hinting and the data validation. Thereafter, the core imports are here, like you have a Chroma, and then you have Ollama embedding, the chat Ollama. And thereafter, we are going to import here a tool, and then we are going to import message state and state graph start and end. Why we need this? Because here in our graph, you will see we have our start node, we have our end node, and then whatever information is flowing from one node to the another node, that information is flowing with the state graph. That is why we need that state graph as well. Now you come back again here, then you see now we import langchain.agent.tool node. So we import this tool node and the tool condition. Before this pre-release version, we used to import these things from the Langgraph, but now these things are actually integrated with the Langchain itself. All right. Thereafter, we are going to load our environment variable. Why environment variable? As you know that environment variables are placed here in .env file. Here is the example environment variable. So we have our Langchain API keys, Langchain, the tracing and Langchain endpoint. All these things are there in this particular environment variable. All right, I have also provided here the example. You can use this example as well. So currently, let me just move out that example here. And this env file, what you see here currently, this is not getting tracked currently. All right. So you need to refer this env example. All right. Having said that, I hope that all these things you have here in .env, and if you have watched the previous videos, then obviously you know that how to do all these things. Let's go ahead and run this. Now it is going to load environment variable, and this says that it has successfully loaded environment variable. Now it is time to connect with our existing vector store. Again, I'm telling you in the first lesson, what we did here, first of all, we had ingested our data into the vector store, and that is the Chroma DB. In that Chroma DB, we had ingested into our vector space. Let me just tell you that that was the collection name, the PDF collection. All right, let's go ahead and in fact, here it is actually. So let me just show you here in the semantic search. Somewhere I must be having that information. Yes, here it is. All right, so the PDF collection. All right, having said that, now we are going to first of all define our Ollama embedding. So one more thing I should tell you here, that whatever method you use to convert your text data into embedding, that same exactly you have to use exactly the same method while retrieving. So we used here the Ollama embedding. So we are going to use the Ollama embedding there as well. So the same configuration we have to use here. So we are using same configuration Ollama embedding here. Other than that, we are also going to connect our vector store with this particular vector store. So currently we are in this directory. We go out one directory, and thereafter we need to go here inside the semantic search and then the Chroma DB. Now we are connected with our vector DB. All right. Finally, we are connected with our vector DB. Let's go ahead and check if we have a successful connection with our vector DB. So we already have a code here. I'm just going to copy this code. With this code, we will know that if we are successfully connected with the vector DB. So this code is provided here in the second lesson. Let's go ahead and run this. As I execute this, it says that 593 documents are found here. If you have watched the first video, then you know that these many documents we had ingested in our Chroma DB. All right, we have successfully made the connection with our vector DB. Now it is time to create our retriever tool. So before we create our retriever tool and before we initialize our model, it is time to go back and see our architecture. So this is the architecture which we are going to follow. Let me just explain you how these overall things are going to work here. So you see what happened here. When your user query comes, so first of all, your LLM is going to decide that whether it need to call a tool or it can answer the question itself. So if it decides to call a tool, then it call the tool, it retrieve the answer, it retrieve the the chunks from the vector database. Thereafter, it decides that whether it is relevant or not. So this relevancy check we are going to do with the grading node. All right, so that is going to be here. All right, generate answer, retrieve, and then while it retrieves, at that time it will also grade the retrieved chunks. After grading, it will decide whether it need to rewrite the query so that it can retrieve the correct chunks or correct document, or it has got the correct document and then it is going to generate the answer. So these things we are going to implement. If you are getting confused, don't worry about that. It is going to be super simple. Once code is implemented, then I'll again explain you that how the overall things are working. So here, first of all, what we do here, we have to create our retriever. So retriever is something which actually retrieves the document from our vector DB. So what I implement here, first of all, I have to do with the tool decorator so that we can convert this Python method into the Langchain tool. So this Python method now gets converted as the tool so that we can use this with our LLM. And thereafter, you see this particular thing is being used as the doc string so that LLM can know that this is the tool which it can use for search and return information for the PDF document database. And thereafter, we print our search query that this particular query is being searched from the vector store. This is a standard method as a similarity search query and k equal to 4. And then it returns the list of the document as I had shown you previously in this particular lesson that it returns the list of the document I might be having here. No, not that one. So somewhere, I guess in the previous lesson, I had shown you all the list of the document, what it retrieves there. All right. So all the list of the document it retrieves. Thereafter, what I do, if there is a document present, thereafter what I do here, I actually combine all the content. So whatever the document is retrieved, all those documents are going to have there the page content and the page number. Let me just show you here. I guess I have those things here. So the tool call when happens here, somewhere I must be having the tool message or something like that. Let me just search here. This is the tool message. So basically, once retriever returns the document, it is going to return all these content along with the page number. You see here, there is the page number, all right, and then the content. So this is something which we are going to prepare. The final output or the final tool is returned. You can watch here. Let me just see that in the retriever. So as you see here, the retriever. So retriever is going to return output with something like this here, what you see. All right. So it has the page number and then the content, all these things it is going to return. All right. So this is prepared here for all document. And then it says that these many documents are found. And then it returns that content here. All right. Perfect. If there is no document found, then it says that there is no document found. Perfect. All right. So that's all it does here. Thereafter, I'm gonna assign this retrieve document as the retriever tool. And then I say that, okay, I have created my retriever tool. That's all I have to do here. Once this thing is done, now it is time to initialize our model. Now let's go back again to our architecture here. So you see here where we have our LLM. So the first of all, we have our LLM here, that is the agent node. All right, so let me just do like this. So this is our agent node, that is the one LLM. Thereafter, we have here, that is the rewrite. So we have our one LLM here, and thereafter here we have. All right, so these are the three LLM. The one more LLM will be having, that is the grading LLM. All right, so whatever you see here at these places, we will be also having the LLM. So wherever I have provided these, the arrow marks, at those places we will be having our LLM. And at these places we are having the tool calls. Let's come back here. Now we have two type of main LLM here. One LLM which generates the answer and the another LLM which actually grade the document. All right, so the document grading LLMs are these LLMs. So this one or this one. And these LLMs are actually generating the answer. So this LLM is actually generating whether it need to call the tool or not. This one is rewriting the query and this one is generating the final answer. So basically the task of these three LLMs are to generate the answer, and task of these two LLMs are to find out whether it is relevant or not, whether particular action need to be performed or not. Having said that, let's go ahead and create these two LLM. So we are going to use the response model with the model Qwen3 itself. And thereafter, we are going to use the another one, the grader model with the Qwen3 itself. So this type of, this type of configuration provide us freedom that we can choose a different kind of LLM for a different nodes. But here, for a simplicity, we are choosing same kind of the LLM for both nodes. Okay, so we have initialized our chat model. Now it is time to work with our node functions. How many nodes we have here? Let's go ahead and see. So we have so many nodes actually. We have here a node, we have there node, this node, this node. So all these nodes need to be implemented. All right. So we have to implement all these nodes here. Otherwise, you can see the nodes here as well. So whatever you see here, this one, this one, this one, and this one. All these are node, and one more node is there, which is the grading node. All right. So which one is going to actually grade the documents? So first of all, we are going to implement our first node. So we have our first node here, that is the generate query or response. So basically this one. So this one is going to either directly generate the response, or it is going to actually decide that whether it need to call the tool or not. All right, perfect. So we come back here, and then what we do here, first we write generate query or respond. And you see here the state is the message state. This message state is coming from here, right? So Langgraph.graph, this is the message state. So the message state is actually the list of the messages. So the list of messages, it is going to be something like this, as you see here. So there is a messages, and then there is the list of messages. You have a human message, you have a tool message, and also you have AI message. All right, you see there. So all these messages are going to be there. So as you see here, this one, all right, the message state. So this message state is going to maintain all those messages together. All right, having said that, let's go ahead and implement this tool. In fact, this node. So we have here response equal to the response model. We have our response model. So which model we have here? This one. And then it is going to bind the tool. Which tool it is going to bind? It is going to bind the retriever tool. All right. And then it is going to invoke with the state messages. All right. So why state messages? Because you see here, if you write there the state, so state is actually dictionary. In that they have a message. So we invoke that with the list of the messages. So if there is a historical message, all those historical messages will also come. All those historical messages will also go into the response model. And that happens if multiple call happens here. So let's say if a multiple loop happens here, in that case, you need historical messages as well. All right. So this is what here happens. And then finally, we return the final response, and that is being returned with the dictionary itself. So it says that messages and the response. The one important thing here, which you need to understand actually, so when it returns these messages, so this is not just a single message, although it looks like it is a single message, but it is not a single message. That is the function of this, actually the Langgraph. When it returns this message, then it automatically get added into the message state. So if let's say 4 messages present there before generating the response, then after generating response, this 5th message will automatically get added into the whole state. All right, that is how these messages, actually the graph state moves from one node to the another node. That is how it is able to maintain all the conversation history, or you can say that the state of the conversation. All right. Having said that, we implement our generate query or respond node. Now it is time to implement our document grading node. So first of all, what we do here, we implement a prompt here. So prompt need to be quite, the comprehensive. So it is like you are a grader assessing relevance of a retrieved document to a user question. Here is the retrieved document. Then you have a context. Here is the user question. All right. So this context is coming from the retrieved document. All right. So because this is the first tool or the first node which you have here, this one have the ability of the tool as well, or it can directly reach to the end as well. All right. So from the tool, it can get the it can get the documents as well. So that document is going to be as the context. All right. And then your question. And then we will be asking our LM to grade whether it is relevant or not. That you can check here. So this one, here it is actually grading. All right. Do you see here a function called document? All right. Check relevancy. So grading is being done here. It need to be graded yes or no. Either it is relevant with the question, whatever the document is extracted, that is relevant to the question or not. All right. Once you have your prompt, thereafter we are going to create here a simple class. And this class is actually like, if you have, if you know the Pydantic models, in that, there is the base model. So basically this is going to be the structured output. In a structured output, we are going to define here that this binary score will return only two kind of output. Either it is going to return yes, or it is going to return no. That's all. All right. So this is defining like, structured output for our LLM. And then we define our method, the grade document. So basically this is going to be a node. All right. So in this grade document, state is being defined here as a message state. Always remember, whatever tool we define, whatever node we define here, all these nodes are gonna have here message state, because it need to maintain the state. And in the message state, thereafter we are also telling our grade document method to return the answer in between only these two options. So basically it will either return generate answer, or it will return rewrite question. It cannot return anything else. All right, that's all. You see here, either it is going to return generate answer or rewrite question. Although you see here, this is a string. Later on, we will check this with the if and else condition, and based on that, we will call a particular node here. All right. Perfect. Thereafter, out of the message state, so whatever messages we have in the state, the first message is always going to be the question. All right. As you see here in the list of the messages, the first message is going to be always a human. And this one is going to be the first question. That is how we choose this as the question. And the last message is always going to be the context. All right. Because whenever your LLM calls a tool and tool returns the document, thereafter you grade the document. All right. So the tool output is actually the context, and the tool output is the last message. Right. So that's how we get our question, and that is how we get our context. Once you have your context and the question, thereafter we are going to prepare our prompt. So you have your context, you have your question. Now we need to format our grade prompt. So we format our grade prompt with the question and the context. Now we get the final prompt. So basically this whole prompt is now going to be inside the LLM. So we have already prepared there a grader model. As you know that we have already used here a grader model with the chat Ollama. In the grader model, all right, we are using a Qwen3. And apart from that, do you remember that this grade document, I told you that this is expecting the structured output. All right, so that is why we are using here grader model dot with structured output, and we pass this grader document. So by passing these two, we tell our LLM that we are expecting output in a structured format. So the output will come into the JSON format, which will have only two kind of output, either yes or no. And thereafter we invoke our prompt here. That's all we have to do here. Once you get the response, then we are going to get the binary score. So the binary score is this one. All right. So in structured output JSON data, we will be getting the binary score. In that binary score, we will be having either yes or no. Now, based on yes, we return generate answer. Otherwise, we return their rewrite question. So you see here what happened basically. If retrieved documents are relevant to the question, then it is going to call this particular node. If retrieved documents are not relevant to the question, that means your LM can hallucinate. In that case, it is going to ask this particular node to rewrite query so that it can refetch document, and then there could be a chance that it might get the correct document. So this particular node is doing that particular task. Let's go ahead and execute this. Now we have our grade document. Thereafter, it is time to implement rewrite node. All right. So let's say if documents are not relevant to the query, then in that case, it is going to return to the rewrite node. In the rewrite node, we need to now implement, first of all, our prompt. So we have our prompt here. So in the prompt, we say that look at the input and try to reason about the underlying semantic intent and the meaning. Here is the initial question. So it passes the question. Then it says that, okay, reformulate this particular question. Thereafter, this reformulated question again goes to the LM. Then it calls the tool, it retrieves, and then it tries to find out the correct answer. All right. Perfect. Now, what we do here, rewrite prompt. After rewriting the prompt, then we need to create our node here. So we have our node rewrite question. So in the rewrite question, again, it is expecting message state. So as I told you that all node will have here type hint, that is the message state. So basically the parameter type is going to be here a message state. So in the message state, we are going to get the messages. So as I told you previously that the first message is always going to be the question. Then we are going to format our rewrite prompt, and then we are going to use here response model dot invoke role user, content is this one, and then finally we are going to return here a message role user, content is this one. Now, do you remember here we are setting role user? So why we are setting role user while returning it? Because we want to tell our LM that this is reformulated question and it is asked by user. It's not AI answer. That is why we are saying here role is user. So with this, we set our rewrite question. Once we set our rewrite question, now it is time to implement our answer generate node. So we are going to implement this particular node here. So what I do here, first of all, I write here a prompt, generate prompt. So I say, you are an assistant for question answering task. Use the following piece of retrieved context to answer the question. If you don't know the answer, just say that you don't know. Use 3 sentences maximum and keep the answer concise. So basically, it is going to generate the answer. And if it does not have right context, then it can just simply say that I don't know. And it is going to generate the answer in very simple format. Here it has the question and here it has the context. This context is coming from the retrieved documents. Let's go ahead and write the method. So we write a method generate answer. In the generate answer, we have our message state. Now this is again going to be used as the node. The first message is going to be the question and the last message is going to be the context. As you know that your AI has retrieved the document from the tool. So that tool message is going to be the context here. Thereafter, we format our generate prompt with proper question and the context. And then we are calling our response model with invoke role is user and here is the content. All right. So this particular prompt with the formatted string with the question and the context goes into the model. The model generates the answer. As I told you here, it is not just returning a single response. Although this returns the single response, but in state what happened? In the state, this gets added into already present message. Let's say if you have 6 messages here, then after returning from this, state will now have a 7 message. So that is how you implement your generate answer. Now, if you notice here, we have implemented all the node. We have implemented this node. We have implemented this node. That is the tool node, in fact, that doesn't need much of the implementation. We have implemented generate one, we have implemented rewrite, and we have also implemented the grader one. And this is the tool node, which we will do later on with the retriever. All right, now it is time to implement our graph. So basically we have all these nodes. All right, this one, this one, this one, this one, all these. Now we need to connect all these in a proper manner. All right, let's go ahead and connect these. So it is time to make our graph. So first of all, we create a workflow, and that workflow is going to be created with the state graph. So state graph we had imported at the start of our lesson. Here it is, state graph. Thereafter we have a start and the end. So first we start. First we start here, and before that we are just first of all going to add all the node here. So first I add generate query or respond node. Thereafter here the tool node. That is what I was telling you here. So this tool node is now, basically this retriever is now getting converted into a tool node using the tool node. We had imported this from the Langchain, and that is going to be named as a retriever. All right, so that is the node here. Thereafter you have here rewrite question node and the generation node. So all these nodes are now present here. Let's go ahead and now start adding the edges. So first of all, we add our start edge, start node with the generate query or respond. All right. As you see here, start goes to this one. Thereafter, it decides that whether it need to call the tool or not. All right. Thereafter, you add here the conditional edges. Okay, at this particular place. All right. So the tool condition is added here. Based on the tool condition, either it is going to call the retriever or it is going to end here. All right. So as I told you previously that, so based on this condition, it is going to decide whether it need to call the retriever. So if it call the retriever, it is going to call this retriever tool. All right. So basically LM decides here. Okay. So whether for a given query, it can answer the question or it need help from the database. So based on that, it decides here. If it can answer by itself, then it goes to the end and answer the result, basically answer the question. Otherwise, it calls the tool and retrieve. Thereafter, what we do here, we connect our workflow with additional edge. After retrieving, we are going to grade our document. So this is what we were seeing here. After retrieving, now we need to make sure that whatever document is actually retrieved, whether those documents are relevant or not. All right. Thereafter, we are adding here additional edge with the workflow that if it is going to generate the answer, then after generating the answer, it is going to end. All right. Otherwise, here in the workflow, we have a rewrite question, and then after the rewrite, it is going to generate the query or the respond. Right. All right. All right. So we have got our graph right now. Thereafter, we are going to compile our graph. So we have compiled our graph. Now, as you know here that we have seen, assembled and compiled the graph. So our final graph is ready here. As you see, this is our overall graph. As I told you, it starts here, then it connects to the generate query or respond. And then based on the tool node, it selects whether it need to retrieve or it need to answer directly. After the retrieve, it goes to the generate answer, and then it also goes to the rewrite question. Once all these things are done, then we come here. Thereafter, we are just going to execute this. Let's go ahead and see our graph here. So this is how our overall graph look like, right? So you start from here, then it goes here, then it decides whether it need to call the tool or it need to go end. Then it retrieve, thereafter it grade the document. Based on that, it decide whether it need to generate the answer or it need to rewrite the question. And thereafter, if it need to rewrite, then thereafter it again goes to the generate query or the respond. Perfect. So our graph is now ready. Now it is time to test our graph. So what we do here, first we define our method run Agentic RAG. We have our question. the question comes here, run the Agentic RAG system with a question. All right. So we pass our question here, and this is like just a simple formatting here. Thereafter, we are going to stream the answer. Basically, we are going to stream the answer, whatever is coming from the LM. So graph.stream messages, this question comes here. Thereafter, we are going to read all the chunks, and in that we are going to actually print everything. So whatever node is being called, wherever your LM is or your agent is executing in any of these node, all these things are going to be printed here. As you see here, update from node. So this thing is going to be shown in our message. That's all you have to do. Now your agent is ready. All right, so this is your agent. Run Agentic RAG. So you just write your question here. Let's go ahead, write your question here. We have our question. What are the main methods mentioned in the paper? So we are going to find out that what are the methods which are mentioned in this research paper. And then we call this method run Agentic RAG. All right, then we are just going to simply execute this. Then we have our question. What are the main methods mentioned in the paper? Now it is executing. As you see here, that update from the node. So which node is getting executed here? The first node, that is the generate query or respond. And here is the content. Let me just do it like this. Then we have a content here. Here it says that, okay, the user is asking about the main methods mentioned in the paper, but wait, the tool provides here are for retrieving the document from PDF in the database. All right, and then the function given is retrieve document, which takes a query parameter. However, the user question is about the paper method. All right, and which implies they might be referring to a specific document they have uploaded or etc. etc. All right, now you see here it is going to call a tool. So here it says that the tool call in the message, and thereafter it is going to call a tool that is the retrieve document. All right, and the query is main methods. Then it called the tool here. So the tool is called. Now it is going to execute the tool here. So after executing the tool, it says that, okay, I'm searching main methods. In that, I have found the four relevant chunks. Out of those 4 relevant chunks, now it is showing here update from the node, that is the retrieve node. As you see, our retrieve node is here. Let me just show you our retrieve node. So our retrieve node is here. All right, so we have got output from our retrieve node. Thereafter, this is the overall content which we have got from our retrieve node, and this could be a quite large content here. As you see here, this is the whole content from our retrieve node. Thereafter, seems like this one is actually relevant. Then it is finally going to generate the answer. So it is going to generate here the answer. You have got the final answer. Let's go ahead and see this answer at the Langsmith. So I come here at the Langsmith. So here in the Langsmith, I have agents, and this is the latest one which I had executed here. All right. If you come here at the top, what are the main methods mentioned in the paper? Then let me just see here, generate query or the response. So what are the main methods executed? All these things we had seen. It calls the retrieve the document, and then this retriever had retrieved the document. All right, so all these documents, got retrieved. Thereafter, as we scroll it here at the bottom, then at the bottom, we can see here, this was the human message. Thereafter, let me just scroll it down here at the bottom. So here it says here. All right, so as you see here, this is the overall output. So in the overall output, it says that the paper mentions several methods, including prompting strategy, zero sort, standard prompting, chain of thought, least to most, decomposition prompting, and all these things. As you see here, these things have been retrieved from our research paper, this research paper. So we have successfully implemented here Agentic RAG with the Langgraph. One more thing I wanted to tell you here, that as I told you while going through the tutorial, that this LM is returning structured output while grading the document. All right, so as you see here in the binary score, it returns here. All right, so whether it is relevant or not. So binary score says that yes, this document is relevant. Let's go ahead and try to execute some other query and then see what happened. So I'm going to ask here which could not be relevant with my research paper. Like, tell me about the Earth. All right. So first of all, it is going to extract the document. Basically, it is going to retrieve the document, retrieve the 4 document, and now it is trying to identify that whether it is relevant or not. Thereafter, it says that okay, it was not relevant. That is why it went to the rewrite question. Then it goes to the rewrite question mode, and then finally, after rewriting the question, then they figure out that okay, this is not related to anything which is present in the tool or in the database. So basically LM need to answer directly from its own knowledge. So here LM answer from its own knowledge. It decides here when LM comes after finding out that the retrieved document was not relevant. When it comes here, then agent decides that okay, seems like, when here it has generate query or response. So here it says that seems like the question which is asked is not relevant to the document which is present in our database, so I can answer this query. So that thing you can actually see in the Langsmith itself. So this was our execution where I asked, tell me about the Earth. As you see here, the detail, first it executed this particular node, then it retrieved the document here. Some of the documents got retrieved here. Thereafter, it called the grading document here. So this particular node, let's go ahead and see what was the output of the grade document. So as you scroll it down, it says that rewrite the question. All right, so that was the output of the grading document. So if you see the output of this Pydantic, then it says that this was not relevant. So binary score is no. Earlier we had seen binary score was yes. And thereafter, finally, your LM decide that, okay, I can write the answer basically. So LM says that, yes, I can write the answer. And thereafter, finally, it thinks that I can write the answer, and then finally it answers here. So as you see here, okay, the user asked, tell me about the Earth. I need to figure out what they really want. The word Earth can mean different thing. Wait, the original question is pretty vague. The user might not have specified which Earth they have interested in. So the improved question could clarify, let me think, etc., etc. And maybe the user is asking about Earth as a planet, etc., etc. And then here is the improved question, and then the reasoning, and then finally it provides here the final output, and this is the correct output. All right, perfect. As you see here that how good your agent is. Your agent is working really good. It is fantastic. So in this particular series, the playlist, we have implemented our semantic search and RAG with the Langchain agents, and then RAG with the Langgraph agents. All right, I hope that this was helpful to you, and it helps you to understand that how overall RAG system works with the line graph and how you can design your own agent with the line graph. All right, so this is all about in this lesson. Please do like this video and subscribe this channel. And also, if it is possible, please do share this video on social media and with your friend. Bye-bye. Take care.